So we are going to run a breakfast delivery service. Yep, breakfast. No worker exploitation here. First on request response microservices, and then on event-driven microservices, so we can see the difference in behavior. So first, our system will look like this. We have a web client, we have an order service, which gets called by this web client, and on getting the request, the order service will call the payment and the delivery service synchronously. Shout out to my boss at Eggy for writing this, Vivian Liang. Thanks, V. And then we'll change it to look like this. We'll still have an order service, which still gets called by our web client, but instead of calling the payment and the delivery service synchronously, it will write an event to Kafka. And we'll have a payment and a delivery worker that each read from Kafka and does its own work. So we're going to call them workers to emphasize that they don't take synchronous calls. And so we're going to run this whole distributed system on this computer, a 2014 MacBook, which hopefully will let us run all of this. So this is our demo code repo, which you can see on GitHub later. Each of our services is a folder in Go services. And each of these main.go files compiles into a binary with Bazel, like so. And here in Protos, the Protos directory, you can see the service definitions for each service. So for instance, the order service has an RPC called create order. The payment service has an RPC called process payment. And the delivery service has an RPC called deliver order. And in the logic for the order service, if we go back to that, we call process payment and deliver order synchronously. And we return successfully to the client only if both of those are successful. So let's run them. This is our order service, which synchronously calls our payment service and our delivery service. And let's go to our breakfast web app. This is also in the repo, so the whole thing should be runnable with instructions from the README. So let's say we want an egg, and a pancake, some bones, and maybe some baguettes. OK, let's place our order. OK, it's on the way. You can see that the order service called the payment service, got a successful response, called the delivery service, got a successful response, and then returned a response to the client synchronously. OK, great. So let's say that now we want more breakfast. But let's say that we're having some iffy network day or something like that, and our delivery service is intermittently available to the order service. So let's emulate that by terminating it. And then let's try again. So this time I want, I don't know, only potatoes. But let's try. Now I can't get them. So what happened? The order service got the request from the client, reached the payment service that succeeded, tried to reach the delivery service, couldn't, and then failed because the order service couldn't reach the delivery service for a second. OK, so that's what happens when there's some iffy cloud stuff going on. Now we're going to do an architecture refactor and switch to an event-driven mode of doing things. So instead of calling the other services directly, like we were doing before, we have a new version of the order service, an async version, which instead will write to Kafka. And we'll have a payment and a delivery worker that each read from Kafka and do their own work. So you can see in this version of the order service, this still uses the same service interface to the client. But in this handler, we are producing to Kafka instead of calling these services synchronously. And in the workers, so this is the delivery worker, for example, we are just consuming from Kafka in this handle function. So let's see what that looks like. Let's go to the async version. And run these guys. We'll run the order async API, the payment worker, and the delivery worker. You know, if it wants to build. So let's go back to our breakfast app and make another order. This time we just want an egg and maybe some pancakes and maybe some bones. Okay. And now this is successful. The user-facing behavior is the same as it was before, which is expected when everything's going well. And you can see the order async API wrote the events to Kafka, the payment worker read it and processed the payment, the delivery worker read it and started the delivery. But okay, let's say just like before, we're having another iffy cloud day, and our delivery worker is going up and down. Let's try to emulate that by terminating it. And then let's try again. This time, I don't know, more potatoes. All right. And now my request succeeds because our backend trusts that this delivery worker is going to come back. Right. And so when it does, it should catch back up and process the order that it missed. So there we go. So the user-facing behavior in this case is quite different from the synchronous one when the cloud environment is being a cloud environment and there are some intermittent issues. But one more thing, so let's see what this looks like if we want to add another piece of business logic or functionality. Let's say, for example, that we want to send users a push notification if they order breakfast to let them, think hungrily about the items that are coming. Well, we think that this should be a straightforward operation. We can just add another worker that's consuming from the same topic. So the idea is that it's trivially easy to add non-trivial functionality to the system. We can just write another worker, and we don't have to change the original order service at all. So let's try that. Make you bigger. And now we should just be able to run this guy. And let's order one more time. Let's say some chocolate, some baguettes. Well, it's not a really nutritious breakfast. Let's try actually something different. Let's do an egg, a pancake, a potato. I feel like I'm being judged for my breakfast choices at the moment, but that's fine. All right, let us submit our order. Please give me breakfast. And the idea is that you can do the same thing to, say, add a worker that sends your breakfast info to a big breakfast advertiser or suck order info into an analytics database for data science or any other type of work. So you can see we got our push notification processed here. And let's look at my phone here. See if I have anything embarrassing on my phone before I do this. Okay, let's see. Please send breakfast. Okay. Oh, you can't see my screen. Oh, maybe you can see my screen. Maybe I need to stop sharing my screen. But you can see that breakfast is on the way. Yeah. Okay. So I will stop talking now.